Cool. So, uh, intro to React. Welcome to React. Um, I would like to talk through the basics. Just kind of, I know you've looked at stuff in the curriculum already. I just want to talk through a little bit about what React is and what it's for from my perspective, and go over some of the basics so we have sort of a framework to learn all the rest of the stuff. Um, I Oh yeah, let's just get started. Um, you have looked at some of the curriculum already, I hope, today. What, before we jump into it, what kind of questions would you want to start off with? Is there anything that you'd like to particularly highlight or anything that like doesn't make sense, even just like what is React at all?
I had a question. I think this was covered in one of the texts, but just to confirm, when we want to create a application with React, it's just an npm install React, or what was?
Cool, great question. We can go into it more as we go along. Basically, you'll do an npx, and that means execute a remote JavaScript package. Npx create dash react dash app, and then the name of your app, and that'll create that directory for you. And then make sure before you start working, go into that directory. Yeah, we'll definitely walk through an example of that and see what that looks like. Cool. Uh, cool. Um, yeah, awesome. What other questions do you have that we want to take a look at?
Would React make my API problem easier?
Depends on the problem.
Okay.
Um, just a preview. Uh, fetch works exactly the same way. It's just a matter of where fetch is getting called from. We'll talk about how that works probably in a couple days. But yeah, the fetch itself, that's going to be exactly the same. It's just a matter of how it fits into React. So short answer, probably no.
All right, thank you.
Cool. What else we got? What other questions do we have?
One thing that kept on kind of making me curious as I went through some of the labs and exercises is when to use function declarations and when to use arrow functions. I think that in a lot of cases, it doesn't change the functionality at all. It might just be like a stylistic preference.
Yeah.
But I feel like there are probably some cases where it has to be one or the other.
The only place, so very quick aside, a function expression is either saying function something equals function whatever or something equals arrow function. The right side of that is an expression, which in JavaScript means something that returns a value, and the value that's returning is the function itself. So that's if you want to, assign a function to a variable to be used somewhere, or like throw a bunch of variables in an object to do a lookup table, a dispatch table, um, stuff like that. I I'm not gonna say never, but I feel like I rarely find myself doing that expression type when I'm assigning to a variable, unless I'm putting together a table or something like that. Whereas the function expression, expressions don't return values. So like if statements, for loops, and whatnot. Functions, the function expression doesn't return a value, but it declares that function, and it does it in a way where JavaScript does kind of a first pass, and then it does all the declarations, and so then they're available to the rest of the file. And that's why you can like write functions at the bottom of your code that you can use above it. If you do the expression part, it's just like any other value. You can't use it until you've declared it. But otherwise, that's the main difference. There may be one or two other very subtle differences that you're probably not going to run into. So for the most part, it's a stylistic choice. If you find yourself getting a like, that's not a function, you probably did a declaration or an expression where you're not using it.
Okay,
yeah,
thanks.
we'll definitely go more into how we do functions and stuff in React as we go along. Awesome question. Anything else about like React that's like just doesn't make sense at all, or
Couple things that I've found tricky are one is like keys. Like there's been multiple cases where
hmm,
thing as far as like visually and how it works on the page seems to work, but I'm not passing the test because it's telling me my keys are not unique.
Yep.
And I've gotten it to pass that test in a certain location and not in another, so just getting a little confused there. And then also and I feel like this might be a tomorrow thing, but like use state. I just watched the video on that. I was like, I don't fucking know what the hell was.
We'll probably talk a little bit about state today. We'll definitely go into it more tomorrow for sure. Awesome. Yeah. Yeah, I'll definitely talk about keys more in detail when we get to that part where we're doing that. Yeah, great question. Keys are non-intuitive, I think. Awesome. What else do we want to talk about?
I was doing the React event handling lab, and I couldn't get the tests to pass for forever, and I finally figured out I didn't have the export default and then the function.
Mhm.
What does that do? Like, what is that?
Yeah. So that's basically so the way we've been writing JavaScript up till now, we've just been doing it kind of like a script. And what that means is when we bring those in, they're all basically in the same big namespace, in that document namespace, which allows us to do some cool stuff, but can get messy. So recently being the last 7 or 8 years, wow, that's not recent, introduced what they call modules. And what that lets you do is basically scope your stuff to a file or a module, which is scoped in that file. And that lets you do things like export things from that module that other things will import. And that lets you keep everything contained kind of in its own namespace, in its own little sandbox. The way you're mostly going to be doing it in React, for components at least, is doing that export default, which just means when someone imports this module, just give them this thing. You can also export stuff by name, which you probably all are already seeing, at least used in React, where you're bringing stuff in the curly brackets. And that's when you say like export this thing by name, and then they can grab just that thing from a module. So it's a great way to set up libraries, a great way to modularize stuff. I really wish we taught it in phase 1 because it makes a lot of sense there too, but we don't yet. Probably never will. Does that answer what you're asking?
Yeah, I think so.
Okay, cool. Yeah, and
I will probably have another question about that at some point. But
yeah, awesome. Yeah, again, not intuitive. None of this is, but definitely used everywhere all the time. And we'll definitely talk a little bit more about it. We'll see as we build stuff. Absolutely do point out things that don't make any sense to you because there's no reason it should. Cool. What else we got? What else do we want to talk about? All right, we got a good list. So this is the part where I talk for a little while. So React. Why don't you start? How would you describe React? And anyone can jump in.
simplified JavaScript.
Simplified JavaScript. Wow. I know a lot of people who disagree with that, but that's definitely one way to look at it. That's a very sunny way to look at it. I love that. What else we got?
Abstracted JavaScript.
Yeah, that's another way. Yeah. Basically, it's a library. It's a bunch of stuff that you can import into your code to make stuff easier, to simplify a lot of the stuff that you would do by hand, like adding stuff to the DOM and changing values of stuff and all that. So it's a library. It's a front end. Some people call it framework. It's not a framework. Frameworks are like Angular or Vue, where basically there's a structure that they set up. Certain things should be in certain places, name certain things, and basically you fill in that structure, and that helps scaffold that app. Whereas React is just like, here's a bunch of things, use them however you like, which works good for some people and works less good for other people. You definitely get used to it. It gives you a lot of freedom, but that freedom comes with consequences, right? So yeah, so JavaScript and React is a JavaScript library, and what that means is under the hood, it is literally just JavaScript. These are just functions and objects and whatever that you are importing and using, but at the end of the day, it's all just regular old JavaScript that does some complicated stuff under the hood. You can go to the React GitHub repo, and all the code is open source in there. If you look in your node modules directory where your React stuff is, all the JavaScript code is right there. And if you feel brave, you can dive down into it and see how stuff works. Some pieces are like literally 1 line long. Some are much larger. But yeah, so nothing magic. At the end of the day, it's all JavaScript.
Could you then say that, or I guess like my question is, can JavaScript, is there anything that, or pardon me, can React do anything that JavaScript can't, or they can all do the same stuff? React just might do it, seemingly with less words.
Yeah, and literally, no, there's nothing that React can do that JavaScript can't, because it is JavaScript. It is written in JavaScript. So, I mean, you could write your own libraries to make a shadow DOM and optimize rendering and all that stuff. You don't want, trust me, you don't want to. But if you had a time machine and went back 15 years and decided to make React just using JavaScript, that's exactly what they did. So it is literally just JavaScript. Everything that's in React, you could do by hand in JavaScript if you wanted to. And a lot of stuff we kind of have been doing, right? But yeah, there's nothing magic in there. No like secret compiled libraries that are hooked in. All JavaScript top to bottom. That being said, when you're writing a React app, you're not writing JavaScript, even though it looks an awful lot like JavaScript. We're writing basically React code with JSX in it, and that's the stuff in the angle brackets that looks like HTML. But clearly, you can't just put that stuff in plain old JavaScript. It just won't work because JavaScript's not structured that way. The JSX and the way that React uses JavaScript, it doesn't run it directly on the page. If you copy pasted a simple React application and just put it in a JavaScript file, it would not work. And that's because one of the cool things that React does is it transpiles. And what that means is it basically just takes some code and turns it into similar code. And what we're doing with React is it's taking stuff that's mostly looking kind of like JavaScript and kind of looking like HTML, and then it takes all that code and turns it into just plain old JavaScript. So whenever you see a like an angle bracket element there, component, each one of those is just turned into a function. Whenever you see a component, that's literally just a function when it gets turned into actual JavaScript. It's a function named whatever the component is named, taking arguments that are whatever the properties are of that. And when we build the components, we write functions. That's one way to do it. That's the modern way to do it. So yeah, if something doesn't make sense, like when we write for or class in React there, those are JavaScript words that it can't really use. So that's why we have to use for HTML and class name instead, so that the transpiler knows like, oh, that's not actually JavaScript, that's code. So bottom line is we are writing JavaScript essentially, but not everything that's in the React component files is pure JavaScript. But it all turns into JavaScript at the end. And it's hard to remember that when you're just coding along. You're like, why isn't my JavaScript working? Maybe React is doing something funky with it. But again, you can look at the JavaScript that it generates. It's ugly, but you can do it. So React is a library that transpiles into plain old JavaScript code, and it uses JavaScript to do that. mostly. So cool. Why would we want to do this at all? As you've probably already seen, it does a lot of the stuff that we do in phase one. More not automatically, but in a more efficient way, in an easier way, I think. So like if you wanted to create an element, I'm gonna say document create element div. I'm gonna say, whatever we call that dot class list, add this, add the text content, add some children, append those, put them in the DOM the right way. If I need to change the value, I need to find what's being changed, change that, and re-render it. You did all this for the last 3 weeks. It makes that way easier. In React, you just say div this thing, and if there's stuff inside it, you put it inside it, and that's it. And it turns that into JavaScript code. So when you see, angle bracket div whatever, it turns that into document create element div blah 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 append. So one of the cool things is it does a lot of that work for you, and that alone is worth the price of entry for me. I cannot tell you what misery we had to deal with before. So yeah, that's one thing it does. The other thing it does is it lets you, when you're doing that JavaScript, it lets you put JavaScript code and variables and whatnot, expressions, lets you put JavaScript expressions, which are what?
Things that have a return value.
Things that return a value, yeah. And that's very important for React. So it lets you put JavaScript expressions inside those curly brackets, and it renders that into your HTML. Fantastic. The other thing it does is it lets us keep state in our components. Like how sometimes we would, when we fetch a list of stuff, we keep it in a global variable. And so we can change that list or object. And when we render that, we don't have to worry about picking stuff out of the HTML and changing it. It just renders that thing. React lets us keep stuff in a state and then use that state in the component. And this is why we use state instead of just throwing variables out there. When we put stuff in state, if we change that state, if we update that state, replace it with a new value, React automatically re-renders the stuff that uses that, and only the stuff that uses that. And we don't have to think about it at all. So much time saved. And yeah, those are the two biggies. It has its own way to do, to do stuff when you load, so you can do initial fetches and stuff. It has its own event handling stuff, so you can do that. So yeah, basically it makes a lot of the stuff that we've been doing already easier. That ease comes with a cost, of course. Nothing is free. There is a bit of a ramp. Definitely not as big of a ramp as there used to be. React today is a billion times better than it was 7-8 years ago. It's so good. It's so good. So that's the why, pretty much. I guess the why part B is that because we're breaking everything into components, it really lets us think more about what we're building in the terms of these functional pieces. So when we were building stuff last phase, we had an HTML page, maybe some divs with some IDs. We'd grab those and kind of like throw stuff in there. And if we had a list, we'd just do that along the way. It's all kind of messy. With React, everything on the page is a component. What's a component? A component is a modular piece of code that puts stuff on your page. So if you looked at that thinking in React page, they have a little example where it's like, oh, here is my here's a shopping list. That's a component. Here's items in the shopping list. Each item is a component. Here's a price or whatever. Here's a form with a button. Everything is a component. So like the wireframes that we did for the projects, if you draw a wireframe broken down into the things that are on the page in useful pieces, you can literally just take those boxes that you drew on the page and turn them into React components, and then just plug them together, and it's a little bit magic. um, and it really lets you scaffold it nicely, so you can go from drawing your wireframe with your boxes and labels, turn that into just components that don't really do anything, that just show you what the page looks like, and then you're already halfway there. And then you're like, okay, cool, these need to have values. What kind of values do I need? I'm going to keep those in states, and then just plug those states in there, and you're most of the way there. Fire up some events and use effects, and you're done. So it really lets you develop a lot more quickly and prototype stuff a lot more quickly, I think. So you can, if you have 3 different wireframes, you're not sure which one you want to do, you just like toss them together in half an hour and then see what they look like, and then pick the one that looks best. Yeah, so that's the why mostly. Yeah, any questions about any of that or stuff you'd like to know more about?
Is it updated often, like every year, 2 years,
All
3
the time.
years?
It's open source, so there's a lot of people contributing to it. They have a roadmap and milestones and all that, and so it updates pretty often. Radical changes don't happen more than every couple of years. They added hooks 3 or 4 years ago, 4-ish, and that completely shifted the way we did stuff, using functional components instead of object-oriented components. Made things a lot easier, I think. Yeah, and there's always new stuff coming up. They have a blog and GitHub release notes, and you can follow them on Twitter or whatever. The cool thing is, when they make updates, you don't have to use them. They pretty much always keep it backwards compatible, and if for some reason there's a breaking change, you can just keep using the old version. It's just a library, you can choose what part you bring. Does that answer what you're asking?
Thank you.
Cool. Yeah.
For the wireframe thing where you could break everything out into individual components, would the CSS work the exact same for that?
Yeah, because the CSS is just operating on the HTML that gets rendered at the end. So yeah, the CSS is just the same as you would on a regular page. There are libraries and processes that let you attach CSS to each component. Styled components, they're called. They may be in the curriculum still. I'm not a big fan of them. Some people are huge fans of them, and it really depends on who you wind up working with. But yeah, but at the end of the day, what comes out on the page is just CSS, and you can just do your CSS just like you did with a regular HTML page. What other questions we have?
So even since we split up, like let's say we're making a web page, even if we split up the codes in like different modules, we still can't share the same class and ID, right?
Yeah, because at the end of the day, again, it's still HTML, so IDs are going to be unique. Classes don't need to be.
Right. Cool.
Yeah. What else we got? Sweet. Cool. So let's walk through a little example of how to make one of these from scratch. Let me go ahead and fire something up and share my screen. Once I get the code up, so I don't need to look at my messy desktop. Terminal, where'd my terminal go? That's a different project. Cool. Let's do that. Yeah, so let me share that. Zoom. Awesome. So that let me grab the chat again. Oops. Zoom. I wish Zoom saved your window positions. That would be real cool. All right, so I'm in my terminal, right? Hello. Oh, why is it up there all the way? Fascinating. Cool. So I'm in my project directory here, and I want to make a new project. And let's I don't know what should we do. Let's make let's make a little like blog looking thing. Why not? So let's make a new project here. We'll do npx, nope, npx. And that does, again, excuse me, that does the remote running of a npm package. If you do, you do npm install global G. Wow. You can install it, or I don't know if you still can do that anymore, because I think I have it installed still. And if you try to use it, nope, doesn't work anymore. Yeah, basically they updated it so you can't run it locally anymore, or you're strongly recommended not to. Lots of things kind of break if they do. So we do npx create React app, and then give it a name, and we'll call it blog. So that will create a new directory and install all the packages and stuff. So it's getting the basic React package. Oh, another cool thing I wanted to mention about React. React is the library that manages state and does like the updating of stuff and all that kind of thing. That itself doesn't do any rendering to a web page. What we have is React DOM, and React and React DOM work together to make web pages. Why are they separated like that? Because instead of React DOM, if we used it React Native, we could keep the same React part, but instead of rendering to a web page, it's rendering out a mobile application. Or we could use React. What's the other one people use? Basically, it separates that functionality between what it's creating. So you can use the same framework underneath to render out different versions. So you can use the same React thing to render out your web page and your React app and your Alexa skill or whatever, using the same core. So there are things you need to do, but it makes things a lot more flexible. So that's kind of a cool thing. Cool. So we've got our React application here. Let me cd into here and code it up, and let's see what we get. Is code going to behave this time? Maybe not. Is code already open? No, a lot of other things are. Oh, there we go. Cool. Thank you, VS Code. So what do we get when we get a React application? A bunch of stuff. Let me talk through a few of them. So any proper JavaScript project is going to have a package JSON that's going to tell us all what we're bringing in. And so we're bringing in all the testing stuff, all the React stuff, and a few things we're probably not going to use. So if like it's just not working at all, these are good places to look. And when you start using other extensions, they'll show up in here. And that's why you can like blow away your node modules or ignore it in the case of pushing stuff up. So this .getignore file says when you make a Git archive, don't keep track of these files, or a Git repo. So node modules is a lot of stuff. So we don't want to push that up to our repo. So we instead push up the stuff without node modules. And then when we do npm install, then it installs all the stuff we need for it. And it knows to like install the dependencies for that, install the dependencies for them. So that's really cool. Makes our repos way smaller. Cool. So that's the npm section. Don't worry about that. Let's look at the HTML page. So in this public directory here, that's where things that aren't rendered via React, like images, or if we have data files sitting around, stuff like that, will be rendered straight from that, or be served, not rendered, straight from that file. We also have our index HTML in here. And this is, if we weren't running anything with React, this is what you would get. Brings in whatever CSS files. Where is it here? Is it here? Do I see CSS in here? There should be. Oh no, because that gets compiled in. But we have, our links and all our titles and meta stuff here. If you want to link CSS in here, you definitely can. I would recommend against linking more JavaScript libraries, but you do you. But the important part is this one div here. So this div is where everything is be hanging off of. Let's keep this open for a second so we can refer back to this. So this is just called root right now. It gives it an ID of root by default. You can give it whatever ID you want. But that means that in our index.js, which is the first thing that gets rendered, and I think, this manifest basically says all the stuff you're including with it, and says where to start. And so it's saying start with the basics, start with our index.js. So after this gets all compiled in, it runs this just like regular JavaScript. And we're going to do a couple things. And we see this is where we're, instead of linking our CSS file, we're importing it so it gets compiled into the whole React application. So we're bringing our CSS in here. Our base component is going to be our app component here. This you can ignore, and all this you can ignore. Don't use that. So we're bringing in a couple things. One from React, which is our core engine, and one from React DOM, which is the thing that takes the stuff from the React core and puts it on a web page. And so first off, we're grabbing our root element. Again, here's our div with an ID of root. So we're just saying document get element by ID root. And we know what that does. So then the special thing that does here is React DOM create root. And what that does is say, hey, I'm going to create the root of a React application, and everything's going to hang off of here. So it's going to basically then render. So it's going to call the render on the root that we created and say, whatever is in here, put that in there. So in the simplest case, we are taking this app component and whatever HTML that gives us, we're just going to put it in root. And so that's all just going to live in here. Cool thing is, you should probably only have one React application per page, but you don't need to make the entire page the application. If you wanted to, you could make a static header and footer and stuff in here and just have the React application render into one part of it. Generally, you're going to do it this way, so just don't have to worry about that. But all it's doing is saying, take whatever you get from app and render that HTML right there into that root. Any questions about what I've talked about so far? All right. So
do we need to link the script anymore for the thing, or does React do that?
Yeah, so React is doing that. When it transpiles, that's when it kind of like grabs the root and follows everything down and bundles all up into one thing. Yeah, so that's why we don't see it including any JavaScript in here, which was very confusing to me the first time I did it. There was no one around to explain it. Yeah, so basically once you've got this part and you go into app, you're in React land. And assuming everything is all set up correctly, most of the time you don't have to worry about anything outside of React. And so what we have here so far, so when we're developing, we are going to be running a server to both serve up our application, our front-end application, and to compile it. So if we do npm start, that is going to, we look at our scripts, and our start script is this. And basically React scripts is a program that the React library gives us that takes the command start and says start. And what that does is it looks in our, looks in the manifest for the root here, and basically processes everything, turns it into the HTML, JavaScript, and CSS that's serving the app, and then serves it up like a web application. So it has basically two functions. And if I did everything right, probably going to give me a page that's not on the screen. Yep, there we go. Localhost 3000 over here. Cool. And so this is what it gives us. This is the default setup that gives you. It's running off of localhost, and we can see over here it's running off of localhost. And the cool thing is, when we change something, and I have it automatically to save when it loses focus, it automatically reloads, and we can see what happened. So I made that change, and when I go off the app, it automatically saves, and then it detects the change, recompiles everything into the React application, and it serves up the new thing. So the cycle of developing, if you've got stuff up, if you haven't set your preferences, autosave unfocused change saved my life. So good. Cool. So this is a server that'll be important when we're working on the backend later on, because we'll be running our front end server and another backend server. So we'll have two servers that talk to each other. For right now, though, just worry about this. This is a server that's running. Troubleshooting tips: if you go here and reload it and you get a file can't be reached, maybe you stop the server. Maybe you Control-C it or close that window. If you try to start up a server and there's already a server running, it may say, hey, can't start it up because that port is already in use. So find wherever you started the last one and shut it down. I don't know how many times people are like, I can't start my server. It says server port use. I'll be like, where's the other one running? And they're like, it's not running. And I'll say, go through all your windows. Show me, show me, show me. Is that the server? Oh, yeah, it is. So computer's not going to lie to you. Just learn its dumb little language. Cool. And so that is how we build an app. This is how we make our window smaller. So we can see here that in the index.js, here's where we're doing the module thing. We're saying import app. And so we're saying import this thing. Could be a function, could be an object, could be a number, could be an array, anything. In this case, it's a function. And in the context of React, that means it's a component. So we're saying import from app. We're bringing in the default thing, and we're calling it app here. If we called it, potato here and potato here, unless I'm lying, that should still work. Great, that still works. So we're bringing in our module, calling it something, and then using that as a component. And if we look in app, here's the thing we were talking about. We've declared a function here, and then we are export default that thing. I usually do it like this, because there's really no reason to do it in 2 lines. So basically we're saying by default, we're exporting this function. And so when you bring it in, bring it in, give it a name, and then use it. And notice that it is in fact a function And what that functions returns is what will be the HTML we want to be on the page. So pulling that thread back, we have our function that returns, we'll call it HTML for now. And so this one says, hey, grab that function. And when we render it, this is React secret code for run that function and put whatever HTML that function returns into the element we made the root, which is conveniently called root here. And everything works like that all the way down. When we make another component in here, and in fact, dirty little secret, these are all basically components. They're elements, but they're basically components. Each one of these, our image, image source equals something, whatever. This is actually arguments. This is stuff under the hood that returns something that looks like, image, blah, blah, blah. So this is a function. This is just a function, even though it looks like HTML. This is matrix down. It looks like HTML. Actually, it's a function that returns HTML that just happens to look like the way that we are calling it. So that we can, with our squishy human brains, write basically what looks like HTML and have that be basically what shows up. Yeah, so all the way down, we're just going to have functions that return stuff that turns into HTML, and that stuff will be, rendered into, this image and paragraph and anchor tag. These are all returning HTML that are rendered into whatever HTML this returns. This returns header surrounded by whatever this returns, puts it in this div. This div creates, quote, less than div, all the other stuff, plus everything the header rendered into it, and that returns it. And that throws it into the app, which is attached here. So all the way down, you're just writing functions that return HTML that all get smashed together in the way that you specify and attached back to your HTML page. You don't need to think about it that way to make it work. You can literally, if you don't care about data or state or anything, you can literally just write HTML components that smack into each other and build a web page and never worry about what it is under the hood. And in fact, you can use state and props and all the stuff that we like to use, and not really worry about too much about how it works under the hood. This comes into handy when you are debugging, when it's throwing errors about functions and that you don't know about. There might be modules or components. Yeah, so it's a lot to take in all at once. I do not expect your brain to absorb any of it right now, but just sort of like have it in the back of your mind as a ghost awareness that what you see isn't exactly what's happening, but it's designed in a way to kind of make it feel that way. Cool. That's kind of the basic mechanics. Ask me some questions because I just talked a lot.
You had mentioned, right, you could have, just a one portion of your application running off of React, right? So
yeah. If I had, around this div, I had a header and a side nav and, footer down here and a bunch of whatever. And then somewhere in that page, I had, it doesn't even need to be a div. I could have a React application that renders list items and render it into, an unordered list. Why not? It's a little bit crazy, but, maybe there's some reason to do it.
Yeah, that kind of dovetails to my next question, right? So like if you technically could kind of mix React and regular HTML and vanilla JavaScript, if you technically could, like, would we ever, like, coming out of the program, like, work at a company that has things all mixed up?
Hopefully not.
Uh,
That said, people do all sorts of things. The God, one of the last places I did a contract for before I started here, they had their this was a live production website at a startup that had customers and everything, and it was running in Angular, which is a different framework. Still JavaScript, still kind of use templates, and well, it's cool, but it's different, super different. They had it in Angular, and it was getting kind of creaky. So they said, "Hey, we should redo our entire business website in React." Brave. So when I was hired because I knew both Angular and React. And what they had done was the website was still being rendered by Rails into an Angular app, but certain parts of it were being rendered into that from React. And I think there were some parts where they had different React roots with different things rendering into it. And they were slowly trying to transition it that way. That was a bad time. People will do all sorts of things. Hopefully you won't wind up in that kind of situation, but inevitably you will, where someone is using some technology that may not exist right now in some ass backwards way that doesn't make any sense. If you're into that, do it. If you can help it, don't be the person that makes that decision, but sometimes you gotta help it. Sometimes it's the best way to do something, like trying to I was working for another place that was, I might have been in a situation a lot, that was converting their Flash and their whole Flash application into Angular. It's kind of the same thing. They had different bits and pieces. So, but there's really no way to do it halfway there. So sometimes you have to do things that don't feel like the best way to do them, but are the only ways you can think of. In anything that we're doing here, all this is made up. None of this is based in reality or physics. This is all just dumb decisions based on dumb decisions based on dumb decisions that people have made over the last 50 years. And there's always many, many, many ways to do something, with their pluses and minuses. So yeah, you can do a lot of things, and as a programmer, sometimes it is fun to do things in a way that's not obvious. And if you can convince someone to pay you to do that, so much good time.
As companies, like, if they want to keep up with the trends, right? Like,
Yeah,
it was brave of them to want to switch to React, but like, if that's the way everyone else is doing things, like, what did you, in your perspective, did a lot of companies, like, as the trends and what's popular changes, do a lot of companies make the big let's just overhaul the whole thing?
unfortunately, yeah. People who make decisions about what we code aren't always technical. And they read an article in Wired or something, and they're like, "Oh, let's change our entire backend to run off of blockchain for some reason," which is never, ever, ever a good idea. Never. But you saw what happened. Everyone and their uncle decided to do that in the last couple of years, and those companies are either not around or have changed their mind, because someone who has a C in front of their title read an article somewhere about how something's the next big thing and they wanted to get on it, whether that made technical sense or not. And after you get to a certain size, even if you're using 10-year-old technology, if it is still meeting the goals, if it's still performing the way that you want and delivering the stuff that you want and serving your customers correctly, leave it. Don't change it to whatever the next big thing is. I'm a big fan. I mean, I'm of two minds, right? I love new stuff. I love playing with new toys. I love hooking things together in ways they don't belong to make them do weird things. But if I'm running a business that I need to keep running and not break, run it in a way that's not going to break, and that includes keeping stable code working. And at some point, that big pile of code may become old and creaky enough, and you're patching stuff with duct tape and restarting servers every 2 hours because of some bug that happens. Then it's time to start thinking about how you're going to transition. But it's a big process. So yeah, and I'm glad I don't have to make those decisions anymore because it's not fun, because someone's not going to be happy. So yeah, yeah. Short answer is you'll see all sorts of crazy shit. Do your best. Get paid for the trouble that it is. And that's my main advice. If it's going to be a huge hassle, charge the amateur hour rates. Yeah, did that somewhat address what you're asking?
Yeah, definitely.
Cool. Awesome. I think instead of building new stuff right now, I think I'm gonna leave it here. Keep it at around an hour. Let you get your hands dirty a little bit, and tomorrow we will talk more focused on building components and using state and all that stuff. But yeah, so this is kind of like general overview, digging into the nitty-gritty a little bit, the whys and wherefores. Wherefore just means why, the whys, and all that. So any more questions like on anything related to this at all? I can talk. Okay, cool. XKCD to Castro. Yeah, for sure. Yeah, I think he's not doing anymore. My friend who was in Chicago coding at nuclear power plants, working on their stuff, and they still use Fortran. No, was it Fortran? COBOL's for bank stuff, I think. It was Fortran or COBOL. That code, was using a language that died 40 years ago. But because it is a nuclear power plant and you cannot install the newest JavaScript library on it and break everything, they kept all their stuff in a 40-year-old language because it worked and it didn't break. And you don't want a nuclear reactor or a spaceship to break because you have a bug in your newfangled code. And man, if you learn COBOL, you can charge a lot of money. COBOL's not a hard language to learn, but nobody wants to because it is ugly and old. But if you can do it, you'll be making like $250,000 a year easy, working for a bank or a power plant. If all you want to do is make money, that's a good way to do it. Notice how I'm not working there. Yeah, teachers don't make as much money as regular developers do, it turns out. But I like it that way. I did that for long enough. Any last questions before we wrap it up? Cool. I hope some of this was useful. I will put up the recording in the usual places on the playlist and in the channel. If you have any other questions, definitely holler in the channel. This is my favorite. This is my favorite part of the course, and so it's the one I know the most about. The one I know the most about because I've spent enough attention on it because it's my favorite one. So yeah, any questions at all you have about anything related to this, holler. I'm happy to give you as surface level or deep as you need. Awesome. On that note, thanks for hanging out, and I will see you all in shortly for stand down.